Okay, number 84. 84 says, what is the correct formula for a compound composed of lithium and the nitrate polyatomic ion? What? Oh, 84. What is the common name, not the systematic or IUPAC name, for this? Really?
Nitrogen.
Ammonia? Ammonia. Ammonia. Remember, ammonia.
The stuff that stinks?
Well, you could say it stinks, sure. Ammonia, yeah, just a second here, okay? So ammonia, remember, it combines with a hydrogen ion, joins up right there, and it makes to make ammonium. So that's ammonium, NH4 with a plus charge ammonium. This is the form you find on the common ions list. Ammonium is listed there as NH4 with a plus charge. It's the same thing as this. This is a structural formula of this chemical formula. Okay? This is a structural formula, a Lewis formula for this chemical formula. Okay? All right. Let's see. Katie, what question was it again? 83? So you want to combine lithium and a nitrate polyatomic ion. Okay, so lithium's Li, you find that on the periodic table. Nitrate is on the common ions list, it's NO3. What charge does the nitrate have? 1 negative. What charge does the lithium have? 1 positive. Found that on the periodic table with oxidation numbers, and this on the common ions list. So that's a 1 plus charge and a 1 negative charge. So what coefficients do I need? None or ones. So this is just going to go together just like that. And there's the formula. I think that was it, yeah.
You did 82.
Sure. Okay. This is a binary compound. Okay. Metal bonded with nonmetal. You know it's a metal because zinc is on this side of the stair step, and you know the sulfur is a nonmetal because it's that on that side of the stair step. And if we're bonding a metal and a nonmetal, what class of compound is this? It's ionic. And using the ionic naming rules, we're going to name the metal what it is, adding a Roman numeral if we have to, and then the sulfur is just going to be written with an IDE ending because it's a binary compound. So the reason we need to find out about the Roman numeral, the only reason we need a Roman numeral is if zinc has more than one oxidation number. And for that, we go to the periodic table with the oxidation numbers and see zinc doesn't have more than one oxidation number. So I just simply call it zinc. And this is sulfide. Zinc sulfide.
Why wouldn't it be sulfate?
Huh?
Why wouldn't it be sulfate?
Sulfate is a polyatomic ion. The ATE or ITE endings are reserved for polyatomic ions. So if you look on the common ions list, you'll find a lot of things in here that have 8 and 8 endings on them. Okay?
So if it's not on the common ions list, then it's probably IDE.
Well, IDE is reserved for, for this class anyway. We reserve it for binary compound. Well, no. Monoatomic anions or binary covalent compounds. Okay? In this class, it's reserved for monoatomic anions. And sulfide here is an S2 negative. Okay? Zinc is 2 plus, and you put them together to make that formula. Okay? So this is a monoatomic anion because it started out as a one atom monoatomic, and we put 2 extra electrons on there to make it an anion. Okay, so anions, monoatomic anions, get an ID ending when it's ionic, and any covalent compound that's not an organic compound, one of those long carbon chains, anything that's covalent, that's binary, we'll use an ID ending for those.
Okay.
Maurice,
Okay, I want you to check something.
what's that?
Number 89, it says balance. This is H2 plus N2,
Mm-hmm.
and there's the arrow NH3. Now, do you put, like, what would I do? Like, oh yeah. Okay, yeah. Don't you put a 2 in front of the N, and then a 3 by the H?
You mean a 2 right here?
Yes.
That would be correct. All right.
Okay.
But let's do what it says to do, because the question says, be sure to include the missing physical states. Okay. What kind of physical state is this going to have?
That's gonna be a H.
No,
Oh, dang.
this is a gas.
What number is
It's hydrogen. Hydrogen gas. You got to know H2 is hydrogen gas.
H?
H2, just H2 is hydrogen gas. When we were doing single replacement reactions, if our product is hydrogen, it has to be hydrogen gas. Okay? And it's listed that way on the activity series, but you got to know that. Okay? Nitrogen, N2. Where do you find nitrogen? Just N2. Where do you find that? Yeah, right here in the air. That's right. It's right. You're breathing it in right now. 70% of the stuff you're breathing in is nitrogen. So what's its physical state? Yes. All right. I know. Nobody wants to answer. Everybody's, scared.
Yes.
Okay. All right. How many hydrogens on the left? 2. How many nitrogens on the left? Listen, guys, I'm balancing an equation for you. Please work with me. How many nitrogens on the right? How many hydrogens on the right? 3. Since our rule is we save hydrogen for next to last, and there is no oxygen, which we save for last, then I need to balance the nitrogens first. So I'm going to put a 2 in front of that. That's going to change the number of nitrogens to 2 and the number of hydrogens to 6. So I need a 3 over here to make that a 6. Okay, it's pretty simple balance. Yep. Sure. 91. H2O2 aqueous. And H2O liquid plus O2. All right. This one also says include any missing physical states. This is a decomposition reaction. And while we're on the subject of classification, what kind of classification is this? Synthesis. Okay, good. All right. What physical state? This is the missing physical state. What physical state do I assign to that? Gas. It's oxygen. That's 21% of what you're breathing in right now. Okay? So let's see. Got to do an atom inventory.
Yeah, 2 oxygens on the left and 3 on the right. There's going to be a lot of change too.
Did I do that part right? Okay, so we need to start with oxygen because hydrogen's already balanced. So let's see, I need a 3 over here and a 2 over here where the hydrogens are. Would that make sense? Or maybe, wait, hold on, let me think about this. I think the simple thing is to put a 2 here and a 2 here.
That's right.
That'll give me 4 hydrogens and 4 oxygens here. It'll give me 4 hydrogens here, and the oxygens you'll have 2 times 1 is 2, plus this 2 times 1 there is 2, so that's 4 there.